Awesome. So we've talked now about sort of energy balance of the Earth. We've talked about how incoming radiation drives patterns of wind and precipitation. We've talked about how local topology, proximity to sort of high specific energy oceans changes local climate. And now we want to step back and talk a little bit about broader temporal scales. So 2.4 focuses on a couple different kinds of things. The one I really, I guess we're on 2.5, but this is lecture 2.4, focuses on a couple different things. It talks about stratification and density of water, which I want you to know. But I think more importantly, for every system, is talking about sort of climate variation over time and seasonality. So this is sort of longer scale temporal variation, and this we call seasonality. And this is driven by the tilt of the Earth. Right? So if we imagine the sun in the center here, here's our little happy little sun. And then we have the planet, Earth, going around it throughout the year with a tilt to it. So this is the axis of rotation that the Earth is going around like this. Whoop. And that tilt is equal to, pause it and see if you know, it's probably the latitude of the tropics, right? 23.5 degrees. Right? So the Earth isn't spinning perfectly up and down in the universe relative to its orbit, which is on this plane here. Right? Instead, it's spinning relative to the orbit at a 23-degree tilt. And that means that at some positions in its orbit, the southern half of the Earth gets much more sun. At other positions in its orbit, the northern half gets much more sun. And that leads to seasonality outside of the tropics. This 23.5 degree tilt is especially important because things below 23.5 degrees up the planet receive less seasonal changes, whereas the further you are away from the equator, the larger those seasonal changes are. So let's look at the South Pole, for example, here. It is getting blasted by sun in our northern hemisphere winter, and the North Pole is getting almost no sun throughout the year because it's pointed away from the sun. At other points in the orbit, the North Pole has daylight for hours and hours and hours, while the South Pole very rarely sees the sun. Alternatively, if you were 10 degrees above the equator, you're almost always getting a similar amount of sun throughout the year. And so that means that seasonality, i.e. change in climate throughout year, is variable across the planet and is highest at high latitudes, right? Furthest away from the equator. This seasonality means that organisms that are adapted to live far away from the equator have all sorts of different challenges than organisms that live at really low latitudes, right? And this pattern of seasonality drives differences in the ecology of organisms. We're really lucky to live here in Florida because we can drive a couple hours north or take a boat a little bit south and really go across this 23.5 degree transition zone where we can see sort of stronger seasonal changes to the north and see how those organisms look very different from organisms in the tropics, which haven't evolved under high seasonal change. Things like deciduous trees, these deciduous oak trees that you see in Gainesville that you don't see down here, versus our live oak trees. They have some up there, but they're more abundant down here. So we sort of see all of these adaptations evolve in organisms that are related to these seasonal changes that are largely driven by the abiotic conditions of the Earth, this crazy tilt in the Earth's axis of rotation. And so seasonality, in addition to all of these global patterns of energy balance and adiabatic and diabatic heating and winds and all of these things you read about up till now, are extraordinarily important in shaping the ecology of organisms, what organisms can live where and how they live their lives. Additionally, for section 2.5, you should read things about ocean turnover and things like this and El Nino. Those are incredibly important. I'm not going to cover them in this lecture because we have a lot to cover this week, but you are responsible for that information. So in a second, we'll move on to the next section of this chapter.